Hello, my name is Volker Sorger. I'm a faculty at the George Washington University in the Electrical and Computer Engineering department. My background was in physics originally, and after studying all the laws of physics and nature, I switched to become an engineer. As an engineer, we design things that make the world a better place, as opposed to a scientist who is curious about the world and studies the world and try to basically understand the world. As an engineer, we try to design and innovate systems which can essentially improve life as we know it. Today we'll talk about engineering and the connection to creativity as it leads to innovation. So let's dive in. This section today has three parts. Basically, we're talking about from engineering to innovation and what the role of creativity might be in that regime. Second part, we talk about teaching and developing creativity for engineering. And I give a few examples what one can do in this kind of space. And thirdly, we will talk about a sneak peek into the future and possibly near future. And we certainly have to ask the question, what does AI, artificial intelligence, has to do in the future? So if we actually look into the development of new and key technologies over the last 2 centuries, we find a bit of a wavy pattern. We find there's a certain development after which there is a boom, or with which there is a boom, after which there's then like a recession and a recovery and a generation, and then a new technology comes that basically keeps on developing. And what we notice in this chart here is that we see that these big cycles come actually in basically increments of 50 years. So that's something like we should keep in mind. Of course, right now, the last one that we are still in and but it's sort of fading out is in information technology. Computers have really revolutionized our world as we know it. And the question is, like, what's next? This is a slide that's possibly like slightly dated, but nanotechnology, energy, these were all like topics that we basically like considered. I would argue data science and artificial intelligence will change our life altogether in the next coming years. In particular, there are a few options that I want to highlight here. For instance, the steam engine has really revolutionized the way we do production and the entire industrial revolution 1.0. Telephone, communication, radio, everyone could be reached now. And then, of course, a transistor, which really enabled telephones and internet essentially in our current dates. And again, these waves essentially come in increments of 50 years, give or take. So if we really ask, how does innovation and creativity move together? Here's basically my take on that. Think about as creativity as this fuzzy space that is that's not exactly defined. It has some sort of round edges, and it is a space where I would say it's multidimensional. It is multi-vectored, so there can be multiple directions that I can pursue within this space, and the process justifies the means. So what I mean by this becomes more clear when we talk about innovation. Innovation for me is something that's very clearly bounded. It has a clear edge upon which a solution does not exist, either physically, because the world doesn't work like this, or maybe viably, because we cannot make essentially like an impact on human life. So unlike creativity, innovation is bound by its standards, its policies, and its physics. It is directed, so it's vectored. It has a certain direction in which it's going, and it's result-driven. If I don't improve upon something, I don't have something that's better to offer, and better can be multi-directed space by itself, it will not improve my system. So the question, of course, how do we get from there to there, or what does creativity, or how does creativity impact innovation in the first place? So the way I basically see this is a bit of a pipeline here. So we first have to have some idea, something creative, something thinking outside the box. From here, we need to apply the rules of physics and of engineering to design something, let's say, this computer as shown in this example here. But it will probably not make it into the marketplace until we make the business case. So it's all about, in the end, money, and there needs to be some sort of incentive created. Money may be just one example. It could be also other directions. But in the end, it will only be truly making an impact if that technology truly addresses a fundamental need or some sort of need of society. So here's an example of this robot puppy, which was one of the flops, so technology flops that did not work out, did not really find anything really useful in the last the last 10 years. Unlike in that little bottle you see on the lower right here, is a lifesaver bottle. It has a grid of 9 nanometer. Like a fine grit. This grid size is 9 nanometer in size. If you take filthy, dirty water and you pump it through this bottle, it turns out sterile, clean water comes out at the other end, because guess what? The size of a bacterium is about 10 nanometers. So you have an 8 nanometer grid, nothing goes through. You can have, well, I'm saying it here, you can have poop water and you can pump it through and you can literally drink it and it's actually sterile. So that could be something. It's very like low tech, no electronics here needed, just a little like hand pump. You can give this basically to like regions around the world that have like water issues. Simple solution. The robot puppy, not so sure. Okay, so the way we think about entrepreneurship and also bringing innovation into the bigger picture is like this. The entrepreneurship 1.0 was basically, there was a threat to my business. I seize an opportunity, I risk it, I do it, and I get something out of it. 2.0 was then we said, nah, that's not enough. Let's really think about productivity. So here, essentially, I'm looking for some sort of effectiveness. And if I compare effectiveness with efficiency in my business by increasing the pipeline, by shortening my supply chain, yada, yada, then essentially I have some sort of benefits for my business. But what we really want to do is we want to enter the field of creativity. The creativity here, the idea is, in this world of entrepreneurship, I take an idea, and once if I can execute upon this idea, it is as if I can multiply my ideas and have network effects. So in 2.0, we really basically had 2 plus 2 is essentially 4. So we had effectiveness and efficiency added to my business. In 3.0, the era we are entering right now with creativity, we are trying to basically look for multiplication effects. Let's say, well, the example I guess I gave just before was not so good. Let me use 5. So 5 plus 5 is 10 in 2.0. 5 times 5 is 25. 25 is 5 times larger than 5. Well, better than 10, 2.5 times. Crap, can we redo that?
Sure, just start at the top.
That's at the top. From threat to vision. Entrepreneurship 1.0 was all about, there's a threat in the world upon which I can find a solution or an opportunity. I execute on this, and basically I have some sort of reward for my business. 2.0 was we're looking for an effective way to execute my business and some efficiency improvements upon this. So this is basically like having, let's say, 5 plus 5 gives you, let's say, 10. 10 is good. However, if you look for in the new era we're entering, the creativity world, we're looking for an idea which I can execute and really share with the entire world and basically broadcast. Here, using 5 and 5 again, 5 times 5 is 25. So that's basically 2.5 times larger than 10. So that's basically what we want to do. And we're looking for basically multiplication factors. Something else, of course, we have to keep in mind with innovations is the law of diffusion of innovation is a fancy word for saying life cycle, product life cycle. So there are some of us who are the innovators, who basically open-heartedly launch into like a new direction. There are some of us who just immediately gets it. They are the early adopters. They are the ones who stand in line at the Apple store the day before the new iPhone comes out, just to be the first to get that new product. And then, of course, at the the early majority, late majority, and the laggards are the only ones who buy like a touchscreen phone or like a key button phone because, or they buy basically a swipe phone because they cannot purchase a keypad phone anymore. So and each of us sits somewhere along this product life cycle with respect to like technology. But the interesting part here is this chasm between the early adopters and the majority. Every company that says, we have a 10% market share, very proudly, 10% market share. They believe they really have sort of won the market. The problem is the system doesn't really get into this like accelerating effects, what Geoffrey Moore calls here inside the tornado. And once you hit 25% market share, the whole system basically like really starts to rise quickly. So the question is, how do you get from 10% early adopters, those who want to just get it anyways, into 25 and 50% market share like eventually? That's this chasm, crossing this chasm. So there's particular strategies we need to think about on how to cross this, like basically how to cross this chasm. The way to do this, or one way to do this, is through having a technology or having a solution that is disruptive. By disruptive, we essentially have a plot like as shown here. We have a cost versus performance. So high cost, low cost, high performance is good. So low in this plot is good. Like down is the sweet spot, versus time. So a given existing technology over time becomes better because it gets developed a little bit, and it has this sort of like a certain scaling factor, relatively flat. As opposed to transformative research, new directions, new ideas, but some of them have fundamental limits, technology-driven, physics-driven, market-driven possibly. So we're looking for that key technology that scales better with time, that basically has different scaling effects. An example from the past was, for instance, voice over IP, Skype, internet calling. It was just a different technology compared to the the classical telephone calling systems. And so the question, of course, for us, if you have a new direction, a new technology, is how do you know, even if you're on the top left on this plot, how do you know that yours is the one that scales all the way down, that scales steep and does not end prematurely? So how do you recognize disruptive innovation? Well, here's a bit of a study. For instance, similar plot again, performance versus time. And just for instance here, I'm showing a few options. Down here, you're in a world where you say, you know what, I have a new technology and it's kind of good enough. It's not great, but it's basically good enough. In this scale then, performance increases. And the idea, for instance, here would be if you have a phone, like if you have a watch, this would be, for instance, like a Timex, and up here would be like a Rolex. So the question is, this is a certain trait of disruptive innovation. It is good enough at the beginning. For instance, here, a Rolex is $2,000, a Timex is $20. When Timex first came out, and I think it was 1950s, 1960s, everybody could have a nice watch which looked more or less like a Rolex. So good enough is an interesting meme once you think about a technology, because every technology, every disruptive technology is an attack from below. It is inferior at first, but it scales better, and therefore it can disrupt the market. Here's another example, photography. When the first photography phones came out, I remember I had my first Nokia phone in 2005. The camera was so poor, and there was no Twitter or no way to share, no Instagram. There was no purpose to even take a phone, to take an image really. So it was a clearly inferior technology. But then, of course, as we know now, it really scaled and really became much better. And there, of course, there's a low-end user, mid-end user, and of course, most demanding user, like the professional photographer, which really needs this high-end system. And what happened, of course, over time, for most of us, I would argue, our phone is truly good enough, and it became quite good. Of course, it was enabled by the CCD camera, and small lenses were developed in the phones, and basically everything became a little better. On the other hand, speaking of phones, the very first iPhone, a device that was able for us to access the internet everywhere wherever we are, it had swipe technology, was truly revolutionary. I would argue now the iPhone, was it like 6, 7, or 10? We need to ask ourselves what really changed, and fundamentally not much changed except for the processor inside was basically replaced. So the same product, of course, this is like product lifecycle again, that at some point was truly revolutionary, could be possibly now boring or uninspiring at this time. So we need to really think about what's the next step beyond this, basically in product lifecycle. The 20th century, interestingly, was really a century of what I call non-disruptive innovation, sustained innovation. Here, for instance, we see the price for a fighter jet from the Air Force as a function of time. And you notice everything scales, well, exponentially here on the y-axis with cost. So if you extrapolate this, by 2054, the entire US Air Force will purchase exactly one plane. And by about 2010, the entire US Army, Air Force, and Navy will all purchase one plane, and they share it between all the various entities. Obviously, something must happen. We cannot continue scaling. So this is basically like a scaling trend, which is really unsustainable. Something else we have to think about with technology is time to market, of course. This here is a prototype, or actually a working system of a surround system that Mercedes-Benz patented in 1898, not 19, 1898. And it was a sort of like a Dolby or like a surround system for a car, which was still being developed. And while was truly like a great idea, it was clearly too early to market. Of course, unlike certain concept cars, which try to combine novel concepts and novel systems, and essentially should be launched right at the right of time when the system is or when the market is ready. Let's talk about design briefly here. We have business goals, and that's basically what is viable to do. We have technological feasibility. Both need to be checked, and we could say the solution of our design lies right in the middle. That's the product that we want to design. The problem is oftentimes we cannot really use them. Like anyone has, for instance, some of these plastic bags are really or wrap up these, for instance, this tool that you bought, but you need basically the tool to open the tool, right? So it's kind of like a chicken and egg problem. This one's also like one of my favorites. So why having two? You can only send one anyway. So it's, you know, think about who's using this. I believe this here is supposed to be a screen on the top right. It is so small you can really not see anything really. So think about who's using it and who's actually like a user in the end. So in order to really make this viable and feasible, we need to add a third part. That's basically like people's desirability. So it's all about humans. We use these technologies, not someone else. So this, of course, reduces my design space, and the product design should really fall into that key region here. And that will be that.
Okay.
Sure how much time I took.
Do you need a break? Or you
No, we're good. We're good.
All right, let's keep
Stretch.
Good. Yeah, keep rolling.
All right.
Awesome. Whoa. Come here. Oh, wrong one. Rookie. Okay. We are rolling.
All right. So in the next part number 2, we're looking into what other little tools that I can give to you, little exercises that you can do exercise with your students or by yourself. We talked about thinking outside the box. So here's this classical old example. You have 9 dots. Imagine you're a forester and you have 9 trees, and you're trying to, for some reason, you can only walk in straight lines, and you're trying to visit every of these trees exactly once with 4 straight lines. Without imagining like you had a pen, without lifting the pen. So you cannot leave the earth, basically, if you're walking around. So if you try this here for a minute, you will find that it's actually rather difficult. But I give you a solution, for instance, here. You start on the top right, you go down, up, down, and to the left. And what you see in here is that I actually left this square box twice, on the top left corner and the top right corner. And essentially what this example shows is if we think outside the box being here an imaginary box drawn around these, basically a square around the circumference of these like nine dots here. If you go beyond this limit, essentially you can solve this problem. So intuitively, our brain looks at these dots and immediately projects a box around them, while in reality, that like no box exists. I never said you cannot go beyond the beyond the borders of this forest. So this is like a very small example of thinking outside the box, quite literally. In terms of fostering creativity, I believe there are 3 principles that could really help us moving forward. One is role play. I encourage my students, actually I do little exercises with my students and playing through a particular scene or playing through a particular ideation process, so idea generating process. I call it ideation. Second one is encourage ridiculous. What it means here is that it's okay to have a laugh. It's okay to think a little crazy at first, but because the process at this stage is unbounded, the process is open, and we should not restrict any possible solution just because it may be a wrong thing to do. So we can always go later on. So once we open the funnel and get all these ideas in this sort of brainstorming-like situation, we can always come back later on and select, down-select, and cluster. And then the third part, which I believe is quite important, is what I call think with your hands. By think with your hands, I mean